Hello everyone, today's lesson is about finding for the volume of a cube and prism. First, let us define what volume is. Volume is the amount of space or the total number of cube inside a solid figure. It also refers to the capacity of containers. And volume is measured in cubic units. Now let's watch this video to learn more about volume.
In this video, we're going to discover where the formula for finding the volume of a rectangular prism comes from. As we did in our last video where we were discovering the formula for volume of a cylinder, we're going to peel away the sides and focus on the base. And since our base is a rectangle, we're going to look at the area of that base, which is length times width. But rather than assume that we know why area is length times width, let's go back and look at what the length and what the width really represent. So first off, for the length, we can really pick any one of these sides, either the two vertical sides or the two horizontal sides. In this case, I'm going to look at the two vertical sides and I'm going to call them my length. This leaves us with our two horizontal sides, which we will call our width. Let's put some numbers into this formula to give us a little bit of context. First, we'll begin with a length of 2, which means we're essentially going to be cutting this shape, this rectangle, in half horizontally. Because our length has a value of 2, we're going to substitute 2 in for L in our formula. For our width, let's sub in a value of 3. That means we're going to be cutting our shape vertically into 3 separate pieces. This also means we're going to be substituting a value of 3 for the variable W in our area of a rectangle formula. By counting up the number of unit tiles in our 2x3 array in our diagram, or by multiplying 2 times 3 in our area formula, we can see that the area of this particular example is 6 units squared. Taking a look at one more example, if our length is 4 and we divide horizontally the shape into 4 pieces, and then look at a width of 6, dividing the shape vertically by 6 pieces, we're going to get an area of 24 units squared. Now that we've looked at some examples for finding the area of the base, let's take a look at how this will relate to the volume of this rectangular prism. As we saw in the volume of a cylinder video, the area of the base is essentially the volume of this rectangular prism with a height of 0. By increasing the height to 1 unit, we can see that we now have some volume to this rectangular prism. We can then increase this rectangular prism to a height of 2 by multiplying the area of a rectangle formula by 2, followed by increasing the height to any value by using a variable. In this case, we're going to use the variable h. And thus, the volume of a rectangular prism can be found by multiplying the area of its base times its height, or in other words, taking the length times the width of the base times the height.
Again, from the video we watched, volume is computed by simply finding the area of its base or the base of a solid figure multiplied by its height. So if we have a rectangular prism, to find for its volume, we will use the formula length times width times height. Now if we have a square prism, again to find for its volume, we will get the area of its base times its height. That's why for our formula, we'll have s squared times height. Now for the volume of a cube, we all know that in a cube, all its sides are equal, right? So if you will find for the area of its base, that will just be side times side, and its height is just also equal to the measure of its height. So instead of using h here, we'll just use s as well, because again, all sides of a cube are equal. So for its volume, we can just simply use the formula s cubed. Now let's try some examples. Find the volume of the figure below. So here we are given a cube. Since the 3 dimensions given here are all equal, And for us to compute for the volume of a cube, we will use again the formula S cubed. Substituting the given information, we'll have 4 centimeters cubed. That means 4 centimeters times 4 centimeters times 4 centimeters, and it's equal to 64 cubic centimeters. Again, volume is measured using cubic units, so we have here cubic centimeters. Another one, again we are given a cube, so we will use the formula S cubed. Substituting the given dimension here or measurement, which is 6 centimeters, we'll have volume of this cube equals 6 centimeters cubed, and that means 6 centimeters times 6 centimeters times 6 centimeters, which is equal to 216 cubic centimeters. Next, this time we are given a rectangular prism. So we have here a length of 22 inches, a width of 12 inches, and a height of 12 inches. So for our formula, we'll use length times width times height. Substituting the given information, we'll have 22 inches times 12 inches times 12 inches, and that is equal to 3,168 cubic inches. Another example. Okay, this time we are given dimensions with fractions. Okay. But again, this figure here is a rectangular prism, so the formula that we'll use is length times width times height. For us to be able to compute for its volume, it will be much easier for us to convert the fractions into decimal numbers. Since the fractions here are 1/2 is converted as 0.5 in decimals. So in our substitution, we'll write 7.5 instead of 7.5. Okay, so we have 7.5 inches times 4 inches times 2.5 inches. And that is equal to 75 cubic inches. Now let's try to solve this word problem. An aquarium is 18 centimeters long, 14 centimeters wide, and 8 centimeters deep. How many cubic meters of water does it contain when it is half filled? Okay, so we have here the keyword half filled. Now, since the aquarium is in the shape of a rectangular prism, we'll use the formula length times width times height. Substituting the given information, we'll have 18 centimeters times 14 centimeters times 8 centimeters. That is equal to 2,016 cubic centimeters. But again, the question is asking for the water the aquarium contains if it is only half filled. So we'll have to divide its volume by 2, and we'll have 1,008 cubic centimeters. Therefore, the volume of the aquarium when it is half filled is only 1,008 cubic centimeters. Last example. How much water is needed to fill the container completely? Okay, so as you can see, we have here a container which is in the shape of a rectangular prism, and it already has water in it, which is 8 centimeters high. Okay. So there are actually two ways on how we can solve this problem. First, we find for the total capacity or the total volume of the container and subtract it to the volume of water it already contains. Or we can just simply subtract already the height. Okay, so 20 centimeters minus 8 centimeters, that will give us 12 centimeters. So we can already say that the height of the container, which is not yet filled with water, is 12 centimeters. And for its length and width, that will just be the same. So for us to compute for the volume of this space here, which is not yet filled, we'll use the formula length times width times height. Substituting the given information, we have 65 centimeters times 45 centimeters times the height, which is 12 centimeters. Again, we are asked to look for the amount of water still needed to fill the container completely. So we'll use the height 12 centimeters in our formula. And that will give us 35,100 cubic centimeters. Therefore, it needs 35,100 cubic centimeters of water to fill the container completely. And that's it for our lesson for today. Thank you for listening.